Hi, everybody. Let's look at Chapter 11, Cloud and Virtualization Security. This is a bit harder for me to have a lot of labs on, but let's look at some of the conceptual pieces. Because just besides doing assignments, you also need to understand what we're doing. So cloud computing just means it's somebody else's computer, really. But part of cloud computing is it's elastic, meaning if I have Amazon, and as I get closer to the Christmas season, I need more server storage space and more server processing power. If you need more, you don't have to put in new hardware in your server center. You just say, hey, I need a little bit more, and you pay more for it. So you pay per use. It's on demand. It can be scalable automatically. And it's very resilient because most cloud providers have servers all over the world. So if one fails, you don't even notice. So here is an idea, or not an idea, but how cloud computing can work. Here we are, WNCC, we go to the internet. Over here is Blackboard. Over here is our Microsoft services. We don't know really where it is, and it's in a bunch of places. So that's cloud computing. Yet again, as I said before, it's really somebody else's computer. There is no cloud. It's on demand. Most of the stuff we're doing is through the web browser, so you can use it on anything. You can have computing resources increased or decreased. Fees are based on what you use. There's different types of clouds. Public cloud would be, for instance, like email. Hotmail.com, Gmail, Yahoo, all of that, anybody can get to it. A community cloud is kind of what we have. Only the right people can get in. Not everybody can get in. The public can't get into our Blackboard. Just people at the WNCC. We really don't have a private cloud that we maintain. It is hosted by Microsoft and other people. And we don't have a hybrid because really we don't host our own private cloud. We have redundant servers at WNCC, but we don't have our own cloud supply. If you were Microsoft, yes, you would have your own private cloud service. We're not big enough to do that. So on-premise means, of course, on-site. Off-premise means it's somebody else's computer. A thin client is a computer that runs from the cloud server. For instance, if you've used a Chromebook, the Chromebook doesn't do anything except run a web browser. Basically, that's all it does. AWS is used quite often for people to host their cloud services on. So they provide infrastructure for cloud providers. We are using software as a service. They provide blackboard.com. We use it. That's it. We're not installing our own specialized applications. We're not deploying our own software. We're not doing anything as a service. Everything we do, and from Microsoft to Blackboard to whatever, we're paying for the service. We're not doing any of those pieces ourselves. Depending on the company, you may do different pieces of that. This is called a three-tier architecture. So this is on the cloud side. So the web servers are the front end. That's the user interface. The application server is like the business logic. And this is where the database is stored. So in computer stuff, this would be called model view controller. This is the view. This is the controller, which controls the interaction between the user and the actual data. This is called the model. And this is a pretty typical architecture. It may be split up into other pieces in between, but this is a very common way to divide things up. So you can have a team working on this. Another team works on this. Another team works on this. It's like separating the logic. So you don't have one big giant monolithic program, just like we've talked about in OS. Everything is in layers, networks in layers. You don't have one big monolithic anything. Monolithic meaning it's a single entity. It's much easier to troubleshoot when you have everything in one big pile. Okay, we're not going to worry about that. Yep, let's keep going. Yeah, I don't know that this is as relevant as what we've been through. Let's see here. That might be it. This is getting deeper and deeper into things that you may or may not. Oh, yes, virtualization. We use virtualization all the time. In fact, cloud providers that provide cloud service, guess what? Everybody uses virtualization in their servers rooms now. WNCC has, I don't know, 40, 50 servers, but physically they may have just 5 or 6. In D1, we added another server, but that server is going to have several virtual servers on it. So a hardware server is not one-to-one with servers anymore. We have used VirtualBox. VirtualBox is a client-side server, client-side hypervisor, which is this one. It's a type 2. It runs like an application, which means it interacts with the operating system. Hyper-V, which we're using in my server room and WNCC uses, runs directly on the hardware. You do have a server installation on the server, which we just set up the other day. When we install Hyper-V, Hyper-V will bypass that and talk directly to the hardware. We'll use the graphical interface of the server to actually manage Hyper-V, but it's not running on that extra layer. So type 2, you have the hardware operating system, hypervisor, guest operating system. Type 1, eliminate the OS. It goes right directly to the hardware. Much more efficient for server type operations. VirtualBox, perfect for what we do in our classes and trying things out and doing test networks. So different types for different needs. Oh, and there it is. Look at there. Nice picture. I was drawing all these imaginary things, and there it is. I forgot it was in there. So this is what we're doing in the server room with my server class. We're going to set up a Hyper-V server. They're each going to have their own virtual machine with their own stuff on it. Hypervisor talks directly to the hardware. Add in this layer, you slow things down quite a bit. It's not as responsive. So VirtualBox is rarely used in a production environment. VMware, Hyper-V, there's others I can't think of right now, they're the major ones that do virtualization in servers. So there is a thing called containers. This has to do with virtual desktop infrastructure. We tried to implement that at WNCC with Hyper-V, and it just didn't really work. You have to have VMware does it really well, but that's a lot of money, and we don't have a lot of money. But that's how it works. Your PC doesn't do anything. It's a thin client. It's a dumb client. We have the hardware. We have the host OS. We have an engine that defines whatever it is that you're going to use. That is all run on the server. What you're seeing is screenshots of what's happening, being passed over the network. Your computer is not doing any work at all. Oh, it would be over here. Your computer is doing no work. Everything happens on the server. So the advantage of VDI is that I could log in from home and have my WNCC desktop. So it's an ideal solution, but unfortunately it costs more money than we have. Virtualization reduces physical costs. It's a lot easier to configure. It's a lot easier to move from one server to the next. You can live migrate from one hardware box to another. You need to upgrade your hardware. Well, buy your new hardware, migrate all the servers over, and decommission the old hardware. In fact, in our server class, that's where we got the servers. IT has moved a bunch of their Hyper-Vs into other servers, and now these are decommissioned. So they didn't have to reinstall anything. They just had to install the Hyper-V layer on the new servers, and then they can migrate all the virtual machines over. You don't have to reinstall things like in the old days when I got started. Virtualization makes management of networks so much easier. You can do software-defined networks. It's not as common as virtualization of things at this point. It is going to become more important. It means basically you use code to say what's going on in your network. I've not actually worked with this. It's not as common in smaller businesses. Let's see, we might be, this goes through the different security concerns. Just like a physical machine, virtual machines need to be set up the same way. Over a network, you can't tell if it's a virtual machine or it's a physical machine. If you're consuming services from a server, there's no way you can tell. And you can use an extra virtual machine for testing things. You can use a virtual machine for testing out programs, or if you think something is suspicious, put it on a virtual machine, isolate it from your network. If something goes wrong, kill your virtual machine and delete it. That's how quick you can get out of trouble. You can get way too many virtual machines and lose track, just like physical servers, but I don't know if that's a huge amount of concern. You do need to harden a virtual host just like you harden a physical host. Hardening means turning off non-essential services, making sure there's no accounts that have weak passwords. That's the sort of thing. You can get a manager that manages a bunch of virtualization things. Our network is small enough, we really don't need that at WNCC and especially in D1. What runs directly on a computer's hardware? Oh, you said type 2? Exactly right. Type 1 goes on the hardware. Type 2 runs on the operating system. I don't know what type 3 and 4 are. I don't even know they exist. Type 1 is the one we use in production. Type 2 is what we use for training and when we're doing virtualization on our desktops. Well, I hope you listened to that and learned something. If you submit a short reflection to me summarizing what were the highlights of this little presentation and email it to me, I'll give you some extra credit. See you later.